Welcome to tonight's edition of Chemistry with Mrs. Flint on the back porch. So in class today we talked about grading papers and how when I'm grading a math question, they're graded out of 5 points. This is the exact same way that Mr. Miller grades. You get a point for your known and unknown. You get a point for having units with all the numbers. If I could get my pen to write here, there we go. You get a point for having a table format when you're doing factor label problems. You get another point for having all your calculations shown. What I'm seeing is a lot of people are leaving off their calculations for the molar mass. If you need to do a molar mass, you've got to show me how you do the calculations. And then the last point is for having the right answer with the right number of significant figures boxed in your final answer. So I was very lenient as I'm grading these papers so far, but starting the next unit, this will be the grading system we'll use. Again, you should be very familiar with it because Mr. Miller did the exact same thing. This is just how I demonstrated that. I'm going to skip it and go straight to the notes. So today's notes were on molarity. So molarity is basically relates to the mole concept, and it's how many moles per liter of solution. So scientists use a measurement called molarity to represent the concentration of a solution. Molarity is going to be symbolized by a capital M, and it's equal to the moles of a solute divided by the volume of the total solution. This becomes a conversion factor. So you're going to have the number of moles divided by 1 liter, and that will equal capital M molarity. Now, solute, a way to say that is solute is the substance or what is being dissolved. If I was making iced tea, I take the iced tea mix, put it in my glass, then I add the water. The iced tea mix is what's going to be dissolved, and that would be the solute. Now, the other term we need to understand is solvent. The solvent is the part that is doing the dissolving. In my example with the iced tea, it's the water that I'm putting in. It's dissolving the iced tea mix. The iced tea mix is the solute, and the water would be the solvent, and both of them together would be a solution. So, when we're talking about solutions, if we have a 1.0 molarity, this means that for every liter of solution, there's 1.0 moles of dissolved glucose per liter of solution. In this case, this would be 1.0 moles in 1 liter of solution. This is a conversion factor. And if we have conversion factors, we're going to be using a factor label method to solve these problems. So there are 3 different steps to actually doing this when you're in a chemistry lab. It says what steps need to be taken to make a 2.00 liter solution of a 1.00 molarity solution of glucose. So the concentration, how strong this is going to be, is 1.00 molarity. So the first step you have to do is calculate the moles of solute needed for the solution. Well, again, this is going to be get my pen going here. This is going to be my conversion factor, 1 liter. This becomes my known. So I'm going to start off with 2.00 liters. That's what I want to make up. Now I'm going to use my conversion factor. If I have liter on the top, I'm going to have liter on the bottom. So 1 liter. And I want its strength to be 1.00 moles. I put that in the calculator, and I'm going to get 2.00 moles. This is a factor label problem. My units are canceling out, and I'm left with moles, which is what I need for this problem. The second step says calculate the mass of the solute needed to make the solution. Well, if we're looking for mass, that's always going to be in grams, which of course is going to stand for grab your periodic table. The 2.1 moles becomes my known. 2.00, I think I just said that number wrong, moles. If I have moles on the top, I'm going to need moles on the bottom, and I'm going to grams. So 1 mole is equal to a certain number of grams, and I have to calculate the molar mass of glucose. Now glucose, the formula is C6H12O6. You should be very good about how to calculate molar masses at this point, so I'm just going to tell you what the mass is. So the molar mass of glucose is equal to 180.18 grams per mole. So this is going to be 180.18 grams. I multiply those together, and I'm going to get 360.36. Now I need to have three significant figures because of this number right here. This has 3 significant figures. So I need to round this. Well, if you round it, it becomes 360. The problem with 360 is it doesn't have 3 significant figures. It has 2, because now you're counting from this direction, and we've got 1, 2. We have to have 3 significant figures in our answer. So there's 2 ways I can show this. I could put a decimal point. By putting a decimal point, now you're counting from this direction, 1, 2, 3. The other way I could show this with 3 significant figures is by putting this in scientific notation. 3.06 times 10 to the second grams. This would also get the unit of grams. So this answer would be correct. This answer would be correct because they both have 3 significant figures. Now when it comes to actually making this up in the lab, you're going to add the mass of the solute to a graduated cylinder or beaker, and then add water until the volume comes to the desired volume. So here's my glucose. You just dump it in your beaker. Then you're going to add water up to 2.00, so it fills the beaker. You're going to stir it so that all of the glucose dissolves. And when you're finished, you're going to have a solution that is the amount of it is the volume is 2.00 liters, and its concentration or its strength is 1.00 molar. So if after we finished with this part of it in class, we went ahead and we moved on to worksheet number 2, molarity calculations, and I'm going to make a separate video for that one.